Alright everyone, welcome back to the day 13 of our daily leetcode challenge, and today we have got minimum length of strings after operations. So in this question they have provided us with a string, and the length of that string can go up till 10 to the power 5s, and we need to do certain operations on this string. What those operations are, what they want us to do is that for each character here, for each character, let's say A or B or C, you need to find the closest character which is equal to this character on the left hand side and on the right hand side, and delete those two characters. Same goes for B. You find the closest characters which is on the left and on the right, and you delete that. And you have to keep doing that until you can no longer do that, and then return the final length of the string. So in the case of first example, we have A, B, AA, CB, CBB. So this is what they have provided us in the first example, and the final answer for this string is 5. Now let's do a quick dry run and see. So out of all the 26 letters that we have, let's start one by one. Let's see with A. So we have A here in the middle, and then the closest we have on the left is this character right here, and the closest we have on the right is this character right here. We delete these two characters. We are left with this string now. B, A, C, B, C, B and B. Now comes B. We have B here in the middle, or we could have chosen this one as well, but we can choose any one right now. Let's start with this one. We have one character on the left here, the closest, and the closest on the right is this. So we delete these two, and then we are left with these characters. Now let's see if we can do for C. We see that for C it's not possible because there is no character on the left in this case, and in this case there is no character on the right. There is no character on the right to delete. So in the end we are just left with this string right here, A, C, B, C, B, which the length of that is 5. So we have 5 as the answer. The second example that they have given us is a AA, and again we cannot do any operations because for this character here we don't have a left character, and for this character here we don't have a right character to delete, so we cannot do any operations. So the final answer is 2. Now before we move further, right, if you take a look what is happening in this string, I'll take another example which is this one, and I'll explain to you something. This is slightly bigger character but length string, but it will help us understand the logic behind the solution that we're going to take. So if you see, right, in each step what we are basically doing is we are reducing the frequency by 2 for each character. Let's say that we have A here, right. Initially, no matter what the count was, the character from the left and the right got deleted, so the frequency got reduced by 2. Same goes for B as well. In this case, we reduce the frequency from 4 to 2. We deleted this character and we deleted this character. Same, if it would have been further more C's here, we would have done the same step for them as well. Let's say we had 2 C's in the end, and in that case as well we would have deleted. At a given step we can only select one character and take the frequency, take the closest from the left and closest from the right, and delete that. So basically you are reducing the frequency by 2 on each step for a single character. That's what we are doing, right? And this will keep on happening until we can no longer divide the reduce the frequency by 2. So what we are basically doing is a division. We are subtracting for each character. We are basically doing a division. And also one more thing that I wanted to point out is there is actually no need to follow the order of characters that they have provided us. What I mean by that is the string that they have provided in this manner. Let me write it again here. This is the original string that they provided us, right? And we are doing operations for characters here. Like we are finding the character B, and then finding the closest on its left, closest on its right, and then deleting that. There is actually no need to follow this particular order. We can just reimagine or rewrite this entire string in this manner. Keep all the A's together, keep all the B's together, keep all the C's together, so on and so forth. Keep all the characters together for a second. Now let's try to see the problem. Now if we kind of separate this problem instead of taking the entire string, if we just separate it by characters and then try to break them, let's say in the first step we are only going to deal with A, in the second step we'll deal with B, in the third step we'll deal with C, and we'll keep on doing that unless we cannot do it for any more characters. So in the first step we are dealing with A's, So again, no matter how many A's we have, we're only going to delete the left and right? For any character, some will be the closest, some will be the farthest, but in the end we are only deleting 2 characters at a time. So we are deleting these 2 characters in the first step, then we are left with this. We sorted this character in this format, then we are left with this now after the first step. Now it's time for B. In case of B, we deleted these 2 characters. Now we are left with, let me draw it here. Now we are left with this, an A here, 2 B's here, and 2 C's here. Now we have to do that with C. Cannot do that because it's at 2. So finally the answer is 5. Let's take another example and do the same process that we just did. Let's take another example. We'll take a bigger string this time. Let's say that we have a string like this. It's form of A, B, C, D's, and it's something like this. Alright, so as we discussed earlier, let us first sort all these. Like, we won't be sorting it in this form, in this algorithm, but let's just kind of rewrite this and keep all the characters, which are all the same characters, next to each other. So after doing that, it will be looking something like these. We have 3 A's. How many A's we have? 3 and 2, 5. So 5 A's here. How many C's we have? 2 C's here. How many D's we have? 3. How many B's we have? 2 B's. How many D's we have? 3 D's. Alright, so now let's start with the breaking part. Instead of doing it step by step, let's separate it by characters. Let's see if we can, let's see how like further down the line this can be reduced to what? Further down the line this can be reduced to what? We have 3 plus 2, 5 A's. After first step, we reduce these two from the first and end, and then we'll be left with 3. After that, we'll reduce these 2, we'll be left with 1. So this entire character set is going to reduce down to a single A. Now let's see with C. Since this is appearing only twice, so we cannot reduce it any further. This is going to turn down as 2 C's. Same thing with B, we cannot reduce it further down, so this is going to reduce to 2 B's. With D, we can delete these 2, this will reduce down to D, single D. So the final answer, since the final answer what they want is just the length, so the order doesn't matter. We can rearrange them in this format and then reduce it. So we have 1 A, 2 C's, 2 B, and 1 D. So the final answer for this string is going to be 5. This will get reduced to 5 after doing all these operations. So if you see, the count that we get for all the characters is either going to be odd length or even length, right? It's either going to be odd length or even length. Now let's see what is happening with, now let's identify a pattern here. What is happening in the case we get characters which are having odd length? Like, let's say we have 3 A's. 3 A's get reduced down to a single A. Alright, let's see what happens with 5 A's. We are trying to identify a pattern. Like, the count is either going to be an even count or an odd count, right? So we'll find what's happening. So in the case of 5, let's see how it's getting reduced. From 5 it's going to go down to 3. From 3 it's going to go down to 1. Alright, that was the case for 5. Now let's see what will happen in the case of 7. Let's say the count is 7. Character could be anything. Let's say the count is 7. So we have 7 A's. From 7, this will, at a time we can only delete 2 characters. From 7 will go to 5. Let's say I deleted these 2 characters. I go down to 5 now. From 5 it will go down to 3. And from 3 it will go down to again back to 1. So if you see, right, what we are getting here is, no matter what the count is, if it's even, if it's odd, like if it's 3, if it's 5, if it's 7, if it's 9, its count will eventually go down to 1. And if it's 1, if it's just 1, then we don't need to worry about it. If it's just A, it's gonna still be 1. So that's the case of odd counts. Now let's see what will happen if the count is even. If the count is even. Now in the case of an even count, right, if we had, let's say, we had 2 A's. As we saw earlier, 2 A's cannot be reduced any further, so this will still remain to 2. Let's say we had 4 A's. We delete these two characters, we are left with 2. Let's say we had 6 A's. We delete these two, get down to 4. From 6 we went to 4. And 4 further went down to 2, right? And then we cannot further delete this, so it's going to be 2. So again, a pattern here as well. If the numbers are even, if the count is even, as in it's like 2, 4, 6, 8, 10, like these, our count will eventually boil down to 2 after doing all these operations. So I hope you are understanding what we are trying to do. What we are trying to do is, firstly, we no need to follow the order of characters that we have. We can simply assign all the A's together, all the B's together. Let's see another example. Let's say we have a string. Let's take an even bigger string this time. Let's say we had a string like this. Now they want us to do those operations, and they want, like, we take the closest character, delete these two. We take the closest character, now these two are gone. We take the closest character, delete this one and this one. Instead of doing all this, let us, first step, let's organize all A's together, B's together and C's together. I'm doing this just on paper. We won't be sorting this in the actual code, because this can be done via hash map as well. We can group all these characters, get the count. I'll explain it to you in the next step when I'll be coding this problem. So first step is to organize all the A's together. How many A's we have? 1, 2, 3, 4, 5, 6. 6 A's. So let me put down 6 A's together. How many B's we have? 1, 2, that's it, 2 B's. How many C's we have? 1, 2, 3, 4, and then I think that's it, 4 C's. And how many D's we have? 3 right here, 1, 2, 3. How many E's we have? 3 right here, and I think that's it. Alright, so I hope I got all the characters. Even if it's not, then it's fine, because I'm trying to make you understand what we did so far. So first step is we organized it. Now let's write the count of each. Now we'll use our previous knowledge that we had. The count of A is 6, the count of B is 2, the count of C is 4, the count of D is 3, the count of E is 3. Just a second ago we realized that if the count is even, it's going to boil down to 2, and if the count is odd, it's going to boil down to 1. We already discussed this and we saw it how. So in the end, after doing all these operations, this is what we're going to finally have with, and then no further operations can be done. We cannot further do any operations for a count of 2, cannot do any further operations for a count of 1. The final answer is going to be sum of all these values right here. So it's going to be 6 plus 2, 8. The final answer for this will be 8. Why so? Because again, we remove these two characters, and that's it, 2. We cannot do any operations, still build 2. Remove these two characters, cannot do further operation, 2. Remove these two characters, 1. Remove these two, 1. The same thing that we did right here. So the final answer for this will be 8, and this is how the algorithm is working. First step is to get the count for all the characters. The characters at maximum will be from A to Z, right? We get all the characters and their counts. Can be easily done via hash map. We'll have all the count for all the A's, all the B's, all the Z's. Now if we see, now we just need to do a simple check. If the count is even, we'll know for sure it's going to boil down to 2, and if the count is odd, we know for sure it's going to boil down to 1. We just saw that. In the end, we'll just get those values, every time we encounter a odd count frequency, we'll add 2. Every time we encounter an even count, we'll add 1 in our final answer, and that will be our answer. So now let's quickly code this up. We will need a hash map to keep a count of all the values. So we have a hash map here. Now let's iterate all the characters in S and get a count of all these characters, be it even or odd. Now the hash map is ready. We'll store our final answer in this variable called answer. We need to do a simple iteration on this hash map. The frequency can either be even or odd. So if the frequency of this particular value, right, is divisible by 2, which means it's even, we saw if it's even then it's going to be 2, so we'll have to add 2 in our answer, else we add 1 in our answer, because if it's an even odd frequency it's going to boil down to 1, if it's an even frequency it's going to boil down to 2. We just saw that, and in the end we're going to just return answer. So we discussed those bigger test case as well. I'll add that test case as well that we just saw, which is multiple A's, B's and C's, which we just saw in our case. This big character, right? It was A, B, A, D, C, C, B, D, E. Let me just run this one and we'll see. So it's, as you can see, it's following all those things that we just discussed just now, and that's how we are getting the answer finally. That's what we have to do basically. Just get the frequency and check if it's even or odd. If it's odd, we know that eventually it will just gonna boil down to 1 after doing all these deletions, and if it's even, it's gonna boil down to 2. And yeah, that's it. And I think if I submit this, it's gonna satisfy all the test cases as well. As you can see, this is a linear time solution, on and o of n, both time as well as space, because we are just iterating the hash map and iterating the character as well. So yeah, big of n, as you can see. Alright guys, that was it for today. Like and subscribe, and I'll see you guys tomorrow. Bye.